Hi everyone, today we explain combination of the functions. Operation on a function. As with a number, if we are given any two functions, f and g, we can operate on them by applying the usual arithmetic operation, as in f of x equal x plus 1, g of x equal x squared minus 1. Then, sum of f and g is f plus g of x equal x plus 1 plus x squared minus 1. Combine like terms and obtain x squared plus x. And product of f and g is f multiply g of x equal x plus 1 multiply x squared minus 1. Apply distributive property, that is, multiply each term of the first parenthesis by each term of the second parenthesis and obtain x squared plus x cubed plus x squared minus x minus 1. As you see, by using or applying the usual arithmetic operation, we obtain the new functions f plus g of x and f multiply g of x. Operation with functions. Sum f plus g of x equal f of x plus g of x. Difference f minus g of x, f of x minus g of x. Product f times g of x equal f of x times g of x. Quotient f divided by g of x equal f of x over g of x, provided g of x not equal to 0. These are new functions which obtain by using or applying the usual arithmetic operation in two functions f of x and g of x. Difference of the function. To find the difference of two functions, f of x equal x squared plus 3x plus 2, g of x equal 3x plus 7, we have f minus g of x equal x squared plus 3x plus 2 minus, always put the second function in parentheses, minus 3x plus 2 in the parentheses, and obtain f minus g of x equal x squared minus 5. Let me to recall, always when you have the negative sign in front of parentheses, you move negative sign, move parentheses, and change sign of all term within parentheses. Or you can thought of as -1 time parentheses, and apply distributive property. Quotient of f and g. If the function f divided by g can be simplified, determine the domain before simplifying. Example. F of x equal x squared minus 4 and g of x equal x minus 2. X not equal to 2 in f of g. Domain of f of g, domain of f divided by g is the interval -infinity 2 union by 2 infinity. F over g of x equal x squared minus 4 over x minus 2. Factor numerator and denominator. Numerator factor x minus 2 times x plus 2. Denominator is factor, cannot factor anymore. So simplify the common factor x minus 2 and obtain x plus 2. Operation with functions. Thus the sum f plus g, the difference f minus g, the product f times g, and the quotient f over g are the new function which are obtained from the function f of x and g of x by applying the usual arithmetic operations. In each case, the domain of the new function is the intersection of the domains of f of x and g of x. So, if the domain of f of x is the set A and the domain of the function g of x is the set B, then the domain of the new functions f plus g, f minus g, f multiplied by g, and f divided by g of x is the intersection of A and B, that is, A intersect by B. Finally, the algebra of the functions is defined as the algebra of the functions, sum, difference, product, and quotient of the function. Let f and g be two functions. The sum f plus g, the difference f minus g, the product f multiplied by g, and the quotient f divided by g, a function whose domains are the set of all real numbers common to the domain of f and g, that is the intersection d sub f with d sub g, where d sub f is the domain of function f and d sub g is the domain of function g of x. So is intersection of the domain of the function f of x and g of x, and defined as follows: sum f plus g of x equal f of x plus g of x, difference f minus g of x equal f of x minus g of x, product f times g of x equal f of x times g of x, and quotient f divided by g of x equal f of x over g of x, provided g of x not equal to 0. Domain of the new function. Example, given function f of x equal 1 over 2x plus 6 and g of x plus 1 over 2x minus 8. Find domain of the new function h of x equal f of x plus g of x. Solution. The domain of f of x is the set of all real numbers x that did not make denominator 0. So, the domain of function f of x is the set negative infinite, negative 3, union, interval, negative 3, infinite. And the domain of the function g of x is the set B equal with the interval negative infinite 4, union 4, infinite. Thus, the domain of the new function h of x, f of x plus g of x will be domain of f of x equal A intersect by B equal interval negative infinite negative 3 union interval negative 3 4 union interval 4 infinite. Composite function. Composite of function is the new operation by which we created the new function. Consider the function g of x equal x plus 2 and f of x equal x minus 1. Using the machine analogy, suppose we input the numbers 1, 3, 0, 5 into machine G and then take the output from this machine and put into machine F as in the diagram. 1305 input in the machine G of x equal x plus 2 and obtain output 3257. And this output I input in the machine f of x equal x minus 1 and obtain the final output 2146. This combined or composite function is written f circle g or f of g of x. Notice that the function g of x is performed first and so is written nearer to the variable x. The set 1, 0, 3, 5 is the domain for the composition function and 2146 is the range. Composite function. There is another operation we can perform with very useful results. It is called composition. It is denoted by F compose G. Note that the little circle, and it is defined by F compose G of x equal F of G of x. That is, given x, first compute G of x, then apply the function f to the result you got from G of x. Composition of two functions. The composition of the function f with the function g is f compose g of x equal f g of x. The domain of f compose g is the set of all x in the domain of g such that g of x is in the domain of f. Composite function f compose g of x equal f of g of x. This is read f of g of x and means to copy the f function down, but wherever you see an x, substitute in the g function. G compose f of x equal g of f of x. This is read g of f of x and means to copy the g function down, but wherever you see an x, substitute in the f function. In general, composition of function, it is not commutative. F compose g of x, it is not equal with g compose f of x. Composite function. The composition of function f with g is denoted by f circle g and is defined by the equation f composed g of x equal f of g of x. The domain of the composition function f composed g is the set of all x such that x is in the domain of g and g of x is in the domain of f of x, excluding value from domain of f composed g of x. The following value must be excluded from the input x. If x is not in the domain of g, it must not be in the domain of f composed g. Any x for which g of x is not in the domain of f must not be in the domain of f composed g. Composite function. Example number 1. Given f of x 2x squared plus 3x, g of x equal x plus 2. Find f of g of x and g of f of x. Solution. F composed g of x is equal f of g of x is equal to g of x squared. Substitute in place of x at the function f of x, g of x, plus 3 times g of x equal 2. G of x is equal x plus 2. Substitute in place of g of x, x plus 2 and obtain equal 2 times x plus 2 square plus 3 times x plus 2. Perform operation and obtain equal to x squared plus 11x plus 14. G compose f of x is equal g of f of x is equal. Substitute in place of x f of x at the function g of x and obtain f of x plus 2 equal 2x squared plus 3x plus 2. Evaluating composition of function. Example 2. If f of x equal to x minus 1 and g of x equal x squared plus 1, evaluate g of f of negative 3. Solution. Find f of negative 3 first. F of negative 3 is equal 2 times negative 3 minus 1 equal negative 7. Then find g of negative 7. G of negative 7 is equal negative 7 squared plus 1 equal 50. Therefore, g of f of negative 3 equal 50. Evaluate composition of function. Example 3. Given f of x 3x squared plus 2x and g of x 3x minus 18. Evaluate the following composite functions. Solution. G of f of 2. Evaluate first f of 2 is equal 3 times 2 squared plus 2 times 2 equals 16. Then g of f of 2 is equal g of 16 because f of 2 is 16. Substitute or plug in place of f of 2 16 and we obtain g of 16, which is equal 3 times 16 minus 18 equal 30. F of g of 7. Evaluating first g of 7, which is equal 3 times 7 minus 18 equal 3. Then evaluating f of g of 7 equal f of 3 equal 3 times 3 squared plus 2 times 3 equal 33.